Okay, the next section is 7.5. We're going to use multiple angles and product of sum formulas. So we'll learn the multiple angle formulas, rewrite them to evaluate trig functions. We'll use power reducing formulas to do the same thing, and half angle formulas. We'll also evaluate trig functions and hopefully do some real life problems in the homework as well. So here are the multiple angle formulas that are on your formula sheet. These three. I actually, once again, didn't put this one because sine is just, or tangent sine over cosine, so you can easily get this just by dividing these two. So let's look at an example then. Let's solve this. To do that, we need to replace sine of 2x using our double angle identity. So we'll make that so on your formula sheet. The formula is 2 sine of x cosine of x. Okay, you can take a look at that. It's right here. Now I can factor out a 2 and a cosine from this, leave me with 1 plus sine of x. Now I can solve both of these parts. So where this equals 0, 2 cosine of x equals 0. Now that's where the cosine of x equals 0. And you can tell in your unit circle the cosine of x equals 0 at pi over 2 and 3 pi over 2. So what I can say for that is I can say pi over 2 plus any increment of pi, because if I go around 1 pi, I get back to here. If I go around another pi, I get back to there. So I'm going to say plus any multiple of pi. So there's an infinite number of solutions for x already, but there are more solutions for x, and they come from this part here now. So I'm going to set that equal to 0. So what I'm looking for then, if I subtract 1 from both sides, is where the sine of x equals -1. Now, the sine of x equals -1 at one spot, and it's right there at 3 pi over 2. So I'm going to write 3 pi over 2, and then it does repeat every 2 pi, so I'm going to have to write 2 pi n here. So there's my infinite number of solutions to this trig equation. Okay, next to my power reducing formulas. These are also in a formula sheet. Once again, not tangent, because if we do need to use that, we'll just use sine over cosine. So let's do an example then. Let's rewrite sine to the fourth as a sum of first powers and the cosine of multiple angles. So we'll change this into sine squared of x times the sine squared of x, and the reason being that on our formula sheet we have formulas for the sine squared of x where it reduces it. Okay, so we can rewrite that as 1 minus cosine of 2x over 2. So we'll do 1 minus cosine of 2x over 2, and then 1 minus cosine of 2x over 2. So now we don't have this power anymore, but we do have a cosine of a multiple angle here, which is fine. So let's we can simplify this a little bit by foiling. If we FOIL, we get 1 minus 2 cosine squared of 2x minus 2 cosine, this is just cosine of 2x. If I add the middle terms together, -2 cosine of 2x. The last times last would give me positive cosine squared of 2x. Okay, so this is all over 4 now. So let me just simplify this a little bit more, because right here we have cosine squared again, which we wanted to avoid that. So let's replace this with, once again on the formula sheet, we have a formula for power reducing formulas where the cosine squared is really 1 plus cosine of 2u over 2, which is right here. So this is a little bit tricky to simplify, but we have 1 minus 2 cosine of 2x plus, and then we have 1 plus cosine of 2x. Actually, this angle goes in right here, so it's going to be 2 times 2x, which is 4x. And that's all over 2 right here, but I'm dividing this whole thing through by 4, so what I'm going to do is divide the 4 into each of them. You know, multiplying by 1/4 here would give you an 8 here in the bottom. That way I can get rid of this 4 from the bottom. All right, and simplify a little bit more, I guess, by, you know, dividing both of these by 1/8. So I have 1/4 minus 2 goes into this twice, so it's cosine of 2x over 2 plus 1/8 plus cosine of 4x over 8. I know this is a lot of work. Let's go a little bit further and add together the 1/4 and the 1/8. 1/4 plus 1/8. Let's get a common denominator and make it 2/8, so it's 3/8. So 3/8. We still have the minus cosine of 2x over 2, and we still have the cosine of 4x over 8. Or 1/8. You can put it 1/8 in front, however you want to do it. But there's my answer. I've rewritten this so that I don't have any cosine or sine squared. I just have the cosine of multiple angles here, 2x and 4x. But that's what they asked me to do. It's a way to rewrite it using our formulas. It's not simplified, I wouldn't consider it, but it's another way to rewrite it. And good algebra practice, especially for calculus, where you're going to have to do this with trig functions via the definition of derivative and definition of integral. All right, so the next are half angle formulas. These are just different formulas. Once again, we'll probably use sine over cosine for tangent. Let's do an example now where we use them to find the sine of 105. So let me rewrite this as the sine of 210 over 2 because we have 210 on our formula sheet for the exact value. And let me write down the formula for the sine of an angle over 2, which is right here, plus or minus the square root of 1 minus cosine of u over. Now, if we wanted to determine the sine here, let's do that first real quick. 105 is somewhere over here and a little past 90. And we know that the sine is the y value there, which is positive. So we know this is going to be positive. We can get rid of that negative sign. So let me simplify this now. 1 minus the cosine of our angle that we're using. This is u right here in the top because it's the formula is the sine of u over 2. So u is 210 over 2. Now, the cosine of 210 is on our formula sheet, or on our unit circle. It's negative square root of 3 over 2. So let's make this 1 minus, double negatives go positive, square root of 3 over 2, all over 2. So let's get a common denominator here. Right, 1 is 2. So this simplifies 2 plus the square root of 3 over 2, all over 2. So now I'm going to move this 2 to the top, and I'm going to multiply by 1/2 instead of divide by 2. In which case I get the square root of 2 plus the square root of 3 all over 4. And I guess I'll do one more thing. I'll take the square root of 4 in the bottom here and pull that out as 1/2. So if I do that, then I just get the square root of 2 plus the square root of 3 all over 2 if I evaluate that square root of 4 in the bottom. And I'll leave my answer like that. So there's my exact answer. Okay, the last thing is the product of sum formulas. I actually didn't include these in the formula sheet because we're not going to use these. I won't give you any problems that involve the product of sum formula for now, or the sum to product formulas either. So let's try the homework and hopefully make more sense of it.